So this is saying I need to find the next 5 terms. I'm going to start with 12. I'm going to have something, 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 something. Wait, find the first 5 terms. We have the first one. I need the next 4 terms, right? Well, the recursive formula is exactly what we need. We need a formula that helps me find what the next term is. So if I want to find, this is going to be a sub 2, right? And this I didn't explain too well last week, so even if you get it, make sure you're paying attention so it helps. If this is a sub 2, and I want to find a sub 2, I'm going to plug 2 in for n. 3 to the a sub 2 minus 1 minus 21. Well, what is 2 minus 1? 1. This is going to be 3 times a sub 1 minus 21. Well, what is a sub 1? 12. That's what's listed in the top of our formula, right? So I'm going to take out a sub 1 and replace it with 12. Now I'm just evaluating this little expression here. What is 3 times 12? 36. What's 36 minus 21? 15. So a sub 2 is 15. Right? That's mathematically exactly what we're doing. Now we can shortcut this, right? My next term is going to be the previous term times 3 and minus 21. So what is 15 times 3? 45. Let's do it right here. 15 times 3 is 45. Minus 21, that gives me 24. Okay? Now I take 24. 24 times 3 is 72. Minus 21 is 51. 51 times 3 is minus 21 is 132. Yeah.
We were supposed to find only the fifth term or all 5 terms?
It says to find the first 5 terms. The first term is always given to you, so you only needed to find 4 more. If you took it an extra step and went 5, that's fine. Arish? Oh, okay. Give me a thumbs up. Is that what you guys got for the next 4 terms in number 4? Melanie, Judah, Ian, Aldrich, Abigail, Yusuf, Davis, Adriana, Prabjoke, Kyan, Anthony. Good. Everyone else? Very nice. Next section, 7 through 12. I feel like we're pretty good with this, but is there any of those that gave anyone trouble, 7 through 12? No? I think we're okay with the writing a recursive formula. Now, 23 through 29. Where do we need some guidance with those? Alex? 29? 25. Let's start with those. 25 is a good one. I like 25. Did you guys like 25?
No.
Why not?
I don't like any of it.
No, more people get it. I get it. I think. Let's see. I don't want to say that yet. There's a lot of stuff I don't get. So 25, what do we got? We got a sub n is equal to negative 7n plus 52. Now the directions say for each recursive formula, write an explicit formula, and for each explicit formula, write a recursive formula. Well, which one is this?
Explicit.
Explicit. How can we tell it's not a recursive formula? Yeah, Tyler? Doesn't have the n minus 1. That's right. And it also doesn't have a sub 1 in the front. So we know this is an explicit formula. The question is this geometric or is it arithmetic? Give me a thumbs up if you say this is geometric. Thumbs down if you say it's arithmetic. Ooh, we must have all had trouble with this, right? This is arithmetic. Okay? It's just simplified. That's all it is. Let's take a look back. Let's stroll down memory lane for a second. Arithmetic was on October 14th. Here it is. Okay. This is how it's set up, but when we simplify it, we end up with something very similar. Let me show you, because it's actually pretty cool. Arithmetic sequence, explicit formula. A sub n is equal to d times n minus 1 plus a sub 1. Now, usually what we do is we plug in the numbers, we distribute the d, whatever that number is, and we can work it out from there. But I don't know what the numbers are right away, so I'm just going to distribute and see what happens. A sub n is dn minus d plus a sub 1. Now, take a look. This is where we got to think critically. If I take my first term in an arithmetic sequence, right, and I subtract the common difference from it, which term is my result? Alex, what do you think?
A sub 0.
A sub 0. Check this out. Let's say I have 3, 5, 7, 9. What's my common difference in this sequence? 2. What's my a sub 1? 3. So if I took a sub 1 and I subtracted the difference, what's 3 minus 2? 1. Does that work out for my a sub 0? Does that fall in line with the rest of my sequence?
Yes.
Yes, it does. So the arithmetic explicit formula is just a sub n is equal to dn plus a sub 0. Now check this out. I can tell from the original formula that I have that my d is negative 7. I'm subtracting 7 as I go. And my 0th term is 52. Right? So let's think about this for a second. If I had an arithmetic sequence where a sub 0 was 52, and each time I move over, I'm subtracting 7. Let me drop this down. What would a sub 1 be?
45.
Be 45, right? I take 52, subtract 7, I get 45. Then it would be 38. Then it would be 31. And we're going all the way down, subtracting by 7, right? So a sub 1 is what I need to write a recursive formula, right? So all this back work, which we don't, necessarily have to know how to do this, but it's good to kind of extend all this learning. All that back work got me to a sub 1, which is 45. Okay? So if I want to write the recursive formula, I know that d is negative 7. I know that a sub 1 is 45. I'm going to define what a sub 1 is. And I'm going to write the recursive formula a sub n minus 1 minus 7. So when you see a function that's written kind of, it looks like slope-intercept form almost, that's an arithmetic sequence that's just been simplified down. Okay? Does that make any sense at all? Thumbs up makes sense. Thumbs sideways kind of makes sense. Thumbs down, you have no idea what I'm talking about. That's fine too. Okay, you're not going to I don't think you're going to need to know how to do that. But it's a good way to use our brains a little bit, I would say. You might not say, but that's fine. Yeah, no, you should be fine. All right. So do me a favor, keep that out.